So the question is, a two fair two two fair dice are rolled. What is conditional probability that first one lands on 6 given the sum of say 2? So or let's just start with 7. So probability of first having a 6 given the sum equal to 7 will be probability of first dice is 6 plus sum of both is 7 divided by probability of sum of both is 7. So what is the probability of sum of both is equal to 7? This we have to make a dot diagram to come up with. So we make a dot diagram like this, and we say 1 2 3 4 5 6, 1 2 3 4 5 6, and then we make these little dots here, 1 2 3 4 5 6, 1 2 3 4 5 6, 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. Now let's see in this which one is going to be 7. So this will be 7. 1 and 6, this will be 7. 2 and 5, this will be 7. 2 and 6 will be 8. 3 4 and 3 4 5 6 7. 5 4, but then you have to do 4 5 6 7, so this one, and 4, and then 5 6 7, and then 6 and 1 7. So 1 2 3 4 5 6, so there are 6. So the total favorable outcomes are 6, and the total possibilities are 36, so that is 1 by 36. So that is the probability of sum of both being 7. So then the question is probability of the first dice being 6, and this answer also we can get from here. Is the first dice is 6 and the sum of both of them is 7, is this only, because this satisfies both the requirements. So this is just 1 by 36. So the answer would be 1 by 36 divided by 1 by 6, or 1 by 36, 6 by 1, or 1 by 6. Let's do another one, which is 2. What is sum of both is equal to 8? And we do the same thing here also. We, let's say, we change to this color here. See, sum of both are 8. So which is 8 here? 1 and none of them is going to be 8, but 2 and 6 is 8, then 3 and 5 is 8, then 4 and 4 is 8, then 5 and 3 is 8, and 6 and 2 is 8. So the number are only 5 now, 5 out of 36. So this sum of both is 8 instead of 6 out of 36. It becomes 5 out of 36. And what is the, among this, which is that the first dial is 6, and that will come out to be just this number. So that will be again 1 out of 36 only, and so on. But what if we say at least one of the pair will land on 6? So the question is, when in this we are saying two fair dice are rolled, what is the conditional probability that the first one lands on 6 given the sum of the dice is 7 or 8? But what if we say at least one of the pair will land on 6? Then in that case, the 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 bottom one uh, becomes the same, the sum of them will remain the same, but the numerator uh, becomes double because the favorable event is now double. It's not just one. The favorable event can be this and this also. So that is why the favorable event in this case, here we are only counting one favorable event, 6 and 1. We're not counting this one favorable event. So the favorable event, in which case at least one pair will land on 6, is going to be this and this. So this become double. In the same case, we are counting this one but not this one. So that's when it becomes double. Okay. Another question is, an urn contains 6 white and 9 black balls. 4 balls are randomly selected. Probability that first 2 are white and last 2 are black. So on 6 white and 9 black balls, and we select 4 balls. 2 are white and last 2 are black. So here the total balls are 15. So we will just calculate the probability. So the first 2 balls are white would be 6 out of 15, and the second one being white will be 5 out of 14, and the third one being black is going to be 9 out of 13, and the next one being black is 8 out of 12. Now there's another question. We have a urn which has 8 white balls and 4 black balls, and we are again taking 4 balls out of it, and we want to know the conditional probability that first and third balls drawn will be white given that sample has exactly 3 white balls. Now this sounds very complex, but it can be solved just by reducing the sample space to the sample of 4. We know that 3 balls are white, right? So out of these 3, what are the possible combinations? So there are 4 possible combinations are 3. 1, 2, 3, 1, 3, 4, 1, 2, 4, and 2, 3, and 4. These are the possible combinations of 3 balls, and out of them, which is the favorable event? So the favorable event is this one. So in which the first ball is white and the third ball is white, and in this case the first ball is white and the third ball is white. So these are the two favorable events. So probability of event is 2 out of 4 or 1 out of 2. Whether you are replacing or not, it will make no difference in the sample space.